Hey guys, today we are going to review using trigonometric ratios to solve for sides and angles of right triangles. Remember, of course, this only works for right-angled triangles. So there are two cases. Case one, where you're trying to find an unknown side. Case two, where you're trying to find an unknown angle. We're going to do one example of each. So let's consider this problem in front of you right now. We have one unknown side as a question mark. I'm going to rename it x, more conventional variable name. And we have a little bit of information. The angle opposite side x is 32.2 degrees, and the hypotenuse of this triangle is 7.15. So you may remember we have three trig ratios. We have sine, let's call it sine of x, cosine of x, and tangent, or tan of x. Now, remember, sine is opposite divided by the hypotenuse side. It's the ratio of the opposite side to the hypotenuse side. Cosine is the ratio of the adjacent side to the hypotenuse side. And tan is the ratio of the opposite side to the adjacent side. So we have a mnemonic device, SOHCAHTOA, that we use to remember this. So you can see it right here. So, S-O-H, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tan is opposite over adjacent. Well, okay, how can we use this to solve our problem? Well, we're given an angle, 32.2 degrees. The first step is to label the triangle relative to this angle. What do I mean by that? Well, we assign sides opposite, adjacent, and hypotenuse based on the angle in question. So in this case, 32.2 degrees, the opposite angle, which is the one right across from it, is x. That's the unknown side. The angle across from the right angle is always the hypotenuse. And the third angle, the other side, third side, not angle, is the adjacent side. So we know that if we look at the sine of 32.2 degrees, that involves the opposite, which is the side we want, and the hypotenuse, which is the side we know. So it makes most sense to use this ratio, sine. Sine of 32.2 degrees is x being the opposite side, 7.15 is the hypotenuse side. So if we want to solve for x now, it's just a matter of multiplying both sides by 7.15. 7.15 times the sine of 32.2 degrees. And now our calculator knows what sine of 32.2 is. It has stored all the ratios for every angle. So it's just a matter now of plugging it into our calculator. If you plug sine of 32.2, making sure your calculator is in degree mode, we can see it is 3 decimal places, 0.533. You should probably keep more decimal places on your calculator to get a more accurate answer. But for the sake of displaying my work, I'm going to round it. Okay, now I multiply that by 7.15, and I would get 3.81 to 3 decimal places. So because we knew that the ratio of x to 7.15 had to be 0.533, because our calculator has that information stored, we can set up a ratio and solve for x. Okay, so now we're going to look at the opposite type of problem. In this question, you can see we don't know the angle, but we do know two sides. So if you ever know 2 out of 3 pieces of information, 2 sides in an angle, 2 of the 3 of those, you can solve for the other. Ignore this 10. That's just a holdover from the textbook I took this question from. Okay, so what do we know here? Well, let's rename this angle. Let's call it A. So relative to A, let's label this triangle. We have the opposite side, which is not really part of this problem, so we probably won't use a ratio that involves the opposite side. We have the hypotenuse across from the right angle. That's 45.8. And 24.6 is the adjacent side. So we can see, we know the adjacent and the hypotenuse. So which one goes with adjacent hypotenuse? That is cosine. Ka is part of, so ka toa. Okay, so let's set up that ratio. The cosine of A, whatever A is, the ratio of its adjacent side to its opposite hypotenuse side is 24.6 over 45.8. And we can plug that into our calculator to get a decimal approximation. Let's see what we get. 24.6 divided by 45.8 works out to be rounded 0.537. So what do we know? We know the cosine of A is roughly equal to 0.537. Now, your calculator not only has all the trig ratios stored, it also knows if you give it a trig ratio, what angle is associated with that ratio. And the button on your calculator, they can give you the angle if you know the ratio is, in the case of cosine, this cosine with a little -1. You see this little -1 floating in the exponent? No, that's not actually an exponent. It doesn't mean anything really mathematical. It's just a notation to tell you it's the inverse of cosine, called arc cosine. And it's just telling you it's solving for an angle when you have a cosine of 0.537. So we can put that in our calculator. Again, making sure we're in degree mode. And what do we get? We get 57.5 degrees with rounding to the nearest tenth. Oh, excuse me, I have disappearing ink on here. Let me rewrite that, 57.5 degrees. So there you go. We've now done one example where we solved for an unknown side and one where we solved for an unknown angle. The most important thing in this question is always to pick the angle in question, label all the sides of the triangle relative to that angle, and then figure out which trig ratio would help you, which two sides are kind of involved in this problem. And then using that, it's really a matter of algebra once you've set it up. Hopefully this helped, and I'll see you guys in class.